it says, this is a very typical question when it comes to the AP exam regarding slope fields and differential equations. You're given a slope field here, and it says that this is your differential equation, okay? So this thing, dy over dx, tells you slope. And it says let f of x be the particular solution with the initial condition 1, 2. That means it crosses through the coordinate 1, 2. So if you notice, over 1 and up 2, that places you right there. What you should do at this point, we're going to give you about 30 seconds. You're going to try to draw the curve that matches the slope field that goes through the point 1, 2. Okay, go ahead. So you can sketch a curve that fits there. Go ahead. Five, four, three, two, one. You should be looking at something like this. You have something like that? Give yourself a point. How many points are each for your response question worth? 9. So you got 1 out of 9 so far. Average is 3. I want to try to do better than 3. Okay. We'll look at the next one. It says write an equation for the line tangent to the solution in part A at the point 1, 2. So we're going to break this into 2 parts. First of all, you're going to write an equation. What 2 things do you need to use in order to write an equation? Slope and a point. This is a non-calculator problem. You would not be allowed to use your calculator. So try to find the slope and try to identify the point and then write the equation. And then we'll go to the second part after that. Da 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 da.
I don't know it.
She doesn't know it.
No.
You've witnessed it 48 times, except for the times that Alex walks in, because Alex doesn't know it.
There's an
I
equal
don't
pass.
know it. It's not that I don't do it.
Oh wow, we plead ignorance. Interesting. Forecast for the rest of the week looks like it should be decent, but it does look like it's going to remain windy for quite a while. So for those of you who are competing in contests on Thursday, it does appear that we're going to have some wind. As of right now, it does appear dry.
Write an equation.
Give me another minute here.
Can I have the paper?
I think that's when you have to show up on time for.
I'm sorry, I was at Mayo.
Well, we'll give it to you anyway. You got a nice drink there?
Yeah, I got it before my appointment.
Five, four, three, two, one. What is the coordinate that it goes through? 1, 2. How do we calculate the slope? The slope is this, right? This says slope is equal to, so we plug in 1 for x and we plug in 2 for y. So you get 1/2 times the sine of pi over 2 times the square root of 9. So I have 1/2 times, what is the sine of pi over 2? 1 times the square root of 9, which is 3. As you multiply those, you get 3 over 2. So therefore, the equation for the line is y is equal to 3 over 2, y minus 2 is equal to 3 over 2 times x minus 1. As we distribute the 3 over 2, we get y minus 2 is equal to 3 over 2x minus 3 over 2. Now we add 2 to both sides, and we get y is equal to 3 over 2x. And then we add 2 to negative 3 halves, and we get positive 1 half.
You can leave it in the other form, huh?
You could leave it just like this if you wanted to. I wrote it like that for this next part. So it says write an equation for a line. We did that. Use the equation to approximate f of 0.8. You do not have a calculator. Simply just plug in 0.8 for x. See what you get. Okay, so the way I would write this, I would go y is equal to 3 over 2 times, and I would write 0.8 as, say, 4 over 5 plus 1 over 2, or 5 over 10. I could see I'm going to get 10 in the bottom there. So y is equal to 12 over 10 plus 5 over 10, which is 17 over 10. So therefore, f of 0.8 is approximately 17 tenths. So it should be shy of 2. Does anybody else write it a different way? 1.7 is fine. Anybody else? Okay, so look at the next part. The next part says it is known that f double prime of x is greater than 0 for -1 to +1. Is the approximation found in part B an overestimate or an underestimate, and why? Give a reason for your answer. Talk to the person next to you about what the heck any of that means and see what you can come up with. Take a minute and a half. Go.
So, I did this part, do that, and then sine of pi over 2 is 1, isn't it?
Yep.
So then how do I multiply that and get 3.5, or is it just 1/2?
So 1/2 times 1 is 1/2, and 1/2 times 3 is 3/2.
Yeah, so then where did you get this?
That's your slope.
Oh.
And you're going to have to write the equation for your y.
Okay. Sorry.
Overestimate.
Because Alex said. You just have that gut feeling.
Okay, here you have it. F double prime is greater than 0. What does it mean for the second derivative of a function to be greater than 0? The curve is concave up. The curve is concave up. So let's look at it. This line is your estimation. Notice that the line and the curve are similar in this vicinity, aren't they? Like the line is an estimation for the curve, but it's not 100% accurate. The further away we go, left or right, the less accurate it becomes, right? Not a good estimation anymore. But right around here, pretty good. So it's wondering, so we found the line tangent at 1. It's wondering about at x equals 0.8, just slightly behind it. Is the line an underestimation or an overestimation? It's definitely an underestimation. So it's an underestimation because it is concave up. So that is your answer, okay? Underestimation.
Because which is concave up?
Because f of x is concave up. Remember, f of x, what f prime of x and f double prime of x tell us things about the original function. What does f prime of x tell us about a function? Increasing or decreasing? What else can it tell us? Local max or local min. If f prime changes from negative to positive, it's a local min. If f prime changes from positive to negative, it's a local max. What about f double prime of x? We said if it's greater than 0, it's a concave up. And if it's f double prime is less than 0, it's concave down. What if f double prime changes sign? What do we have at that spot? A point of inflection. Okay, so we're now going to take this right here and we're going to write it down on the opposite side of this paper. Okay, so I'm going to extend this further and I'll write this down. And what we have is dy over dx is equal to 1/2 sine of pi over 2x times the square root of y plus 7, given f of 1 is equal to 2. So just to be clear about notation, f of 1 is equal to 2 and y of 1 is equal to 2. Those are synonymous, except for the fact that if it's labeled f of 1 is equal to 2, then you know that it is in fact a function, which means it passes the vertical line test and all those characteristics of a function. There's really not anything that you would need to disseminate at this time between f of 1 or y of 1. I just wanted to make sure you knew that. So first step you want to do, separate the variables. So you want dy on one side, you want dx on the other side. Gather your x's and your y's, just separate the variables. Go ahead and start with that. Take a minute and do that. So by the way, that last problem was worth 2 points, so you're at a total of 5 points we've accumulated so far. So the separation of variables is only worth 4 points. So I don't think that that's a bad 5 points to try to get. You're going to get another point just for separating variables. Okay, let's see what you got. You should have the following. 1 over the square root of y plus 7 dy is equal to 1/2 sine of pi over 2x dx. Okay, we get all the x's on one side, we have all the y's on the other. Did you get that? If you separate the variables correctly, they will give you 1 point for that. And I don't think that that's a tough way to get a point. Get my point? All right, so now what I want you to do is I want you to, this will be tough for some of you, I would like you to take the antiderivative of both sides. I'm going to give you a good 2 minutes to do that. Another minute or so. Okay, let's see what you got. I think that this side is going to be a slightly easier option. The antiderivative of this, we raise the, notice this is a negative 1/2 power because it sits in the denominator. So if you raise it by 1, you're going to get y plus 7 to the 1/2. And you're going to divide by 1/2 and multiply by 2. So that's our antiderivative, yes.
I thought it was the natural log.
Nope, if it's 1 over the y plus 7, then it's the natural log of y plus 7. But since it's to the 1/2 power, we can increase. Okay, so that's the left-hand side. The right-hand side, you must use substitution. And so we set up u is equal to pi over 2x and du is equal to pi over 2 dx. We don't have a pi over 2, we have a 1 over 2. So I'm going to divide by pi, or rather 1 over pi du is equal to 1 over 2 dx. So now I have my substitution, where I have a 1 over pi times the integral du, and that allows me to get rid of the 1/2 and the dx, and I'm left with sine of u. What's the antiderivative of sine of u? Negative cosine. So we get negative 1 over pi times the cosine of pi over 2x plus a constant.
I'm so confused now.
Which part?
Where did the 2 come from? On the other side.
Here?
Yeah.
So suppose you have 1 over the root of x. So that's equal to x to the negative 1/2.
Yeah.
So I would add 1 to get x to the positive 1/2, and you divide by 1/2, which is the same as multiplying by 2. Okay? All right, so there we have that. Show of hands, who got this antiderivative? Show of hands, who got this antiderivative? Good work, good job. So my guess is that they would give you 1 point for coming up with each of those antiderivatives. Okay, that's typically how they do it. Now we need to solve for our general solution. Okay, the general solution, we will divide by 2. We'll get the root of y plus 7 is equal to negative 1 over 2 pi cosine of pi over 2x plus a constant. And then finally, we will square root both sides, or square both sides, and we get y plus 7 is equal to negative 1 over 2 pi times the cosine of pi over 2x plus c, that quantity squared. And then finally, we'll subtract 7, and y is equal to negative 1 over 2 pi cosine of pi over 2x plus the constant quantity, minus 7. And that quantity is squared. So we solve for the general solution. So what I would like, yes?
So if we have the plus c on that side, what happened to it on the other side? Because I put it on both sides, and then we can just subtract 5c.
So this would be a situation, say this is one constant and this is another constant. When we join the constants together, we just get another constant. So the constants just float around. So.
I see.
All right, so now you have a coordinate to be able to work with, and that coordinate is, in fact, what are we using for our particular solution? 1, 2. It stayed the same throughout the problem. Sometimes it changes. So now what I would like you to do is go ahead and see if you can determine what C is given the coordinate 1, 2, and that will satisfy our work for the day. It's a really nicely designed problem. I like it. You got 3. So as you glance at this, it's important to note that if you plug in 2 for y and you add the 7 over the other side, you do get 9. The other important thing to note is if you plug in 1 for pi over 2 and note you don't get your calculator, you must know that the cosine of pi over 2 is in fact 0. And so that will cancel out the negative 1 over 2 pi. So you get 0 plus c is equal to 3, so therefore c is 3. So to finish off this problem, you would write the very last piece, which is y is equal to, parentheses, negative 1 over 2 pi times the cosine of pi over 2x plus 3 quantity squared minus 7.
How much time do we get on
15 minutes per
all of them? So all the 9?
for free response problems. Yep.
Like the whole thing?
So that piece right there is 15 minutes. So you would have 6 of those. Generally, the reaction is from people that they worry that they're not going to have enough time. The reality of the situation is that even though we cover many varieties of these problems in class, people get to the test, they do not recognize the form. And so out of the 6 problems, they generally say, oh, I know how to do one, and I kind of know how to start another one. And so therefore they sit for about a half an hour with nothing to do. Or an hour with nothing to do. So generally, in this class, being pressed for time in the AP exam is not a problem. Usually people say, I don't know how to do enough of this stuff, such that I don't have anything else to work on. So I had a student come back one time. They were a 33 ACTer. They were really smart. They came back. I said, how'd it go? They said, oh, it's horrible. They said, like nothing you taught us was on that test. I'm like, really? So that's too bad. They're like, yeah, there's like only one problem. The rest of it was just gibberish. I said, out of the 6 free response, they're like, yeah, only one. And then another kid came back who got like a 25 on the ACT. I said, oh, piece of cake. I said, really? I said, out of the 6 problems, I said, how many seem familiar with what we did? He's like, all 6 of them. I said, yep, I classified them all. I knew. So the one group, the kid who got 25 on the ACT, but really knew his calc because he leaned in really hard, he got a 5 on the AP exam. The other 2 kids who got 33s on the ACT, but they're just always used to just being smart at everything and not really investing their full self. They got the 2. So there's nothing wrong with the 2. But there'll be people in here who get 1s. There'll be people who get your 2s, 3s, 4s, 5s. We'll have the full spread of data. But I just want you guys to know the difference. It doesn't mean just because you did well in trig or just because you got a good ACT score that you're all of a sudden just going to eat this up. So none of this content was on the ACT, was it? Absolutely not. And to be clear, you guys, I don't ask for anybody here to get a 5. I just ask you to try each day. And so the fact that you guys tried this problem, that makes me happy because like last year, people were putting this off and they were talking, they were doing their notes for current events day and stuff like that. And then they got angry, Mr. Gantz, and I yelled at them. And then they were like, oh, he's a mean guy. Yeah, I am mean. Yeah. Don't like it, get out. What do you think?
Yeah.
Turn to the person next to you, now that you've seen it. Out of the 9 points, how many points do you think would be reasonable for you to get if you saw another problem similar?
3 or 4.
What do you think we shoot for? Okay, talk.
Well, I know how to know the so too.
I got a picture.
Yeah.
That's where you take those.
I can get that. I can get one.
That's
I
child.
remember you had to put it.
No help.
Like, I feel like your brother, he was just gonna say it's like that.
Yeah, so you're
After that.
I got 6.
No.
If I would've known it, if I
That
would've
would've
myself
been,
into
I might not have gotten some.
Great.
Some kids are full time to do this.
Okay, national average is generally about a 3 to a 4. Our average is usually right about 2 points. So you guys think you could get more than that?
We'll see. I would think so.
No.
I mean, sketching the curve is, so here, to me, here's where you automatically get the 2 points. You sketch the stinking curve, and then you separate the variables. Like that's 2 points right there, right? I mean, hopefully we could do something else along the line. I get it. You don't remember the concavity piece or something like that, so be it. But I think you can automatically do the 2 points and try to move on after that. So I'm going to stop this video.